Hey everybody, this is Larry. This is day 6 of the May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Convert sorted list to binary search tree. Convert it to a height balanced binary search tree. Okay. This is still this is just annoying. It's fine. Basically, it's a sorted linked list. Okay, still fine. It's how do I want to do this? This is just like an annoying, messy one. Or implementation. Well, it's not all implementation. It's just about fundamentals, and then after that is implementation, which is divide and conquer and so forth. How do I want to do it? I mean, it's going to be divide and conquer in some way. You basically just keep on taking the middle or the median. Well, I guess that's the middle. I'm trying to think whether you can get unlucky and it becomes like a linked list by accident if you keep on. I don't think so. Well, it's not off by that much. Maybe I'm wrong on that one. But okay, so I mean, I think it's just about having helper functions. Let's see, right? So basically, what we want to do is, let's do it as naively and as silly as possible, and then if we run into issues, we'll run into issues, and then we'll figure out how to solve them. We're smart people; we could figure it out. Yeah, let's do a get length maybe of a node, and then this is just current is 0 to no. Wow, no that. Next, return count. Of course, I skipped some stuff, but this may be off by 1. I never know. I think this is 1 actually, but I guess this assumes node is not none. So yeah. The way that I usually do this is a little bit differently, because I have a fake head. But yeah, I guess I should actually think about that case. Okay, and then now let's just have a. How do we want to write this, right? Well, let's just have a. I don't know if I need another helper. That's why I'm not sure about how to structure the code yet. But okay, let's say n is equal to length of head, and then now we want, and these helpers are, it does add iterations to this, but I am okay. Actually, you can probably you don't actually need this. You can also just do the fast slow thing to get the medium node. So maybe we can do that instead. Let's just get middle. Is that annoying? I'm trying to think about what happens if there are. No, let's just keep it simple for now. We can be clever with fast slow nodes or whatever, or fast slow Freud's method or whatever it's called if we want, but let's just keep it this way, so then we can get yeah. Let's just say return get BST of head, and then now let's actually implement get BST with a node. Let's first by getting the length, and then now let's get the middle. Middle is equal to head for something like that. Middle is equal to middle dot next. I think that should be good, inclusive. And then now middle is now the root. Middle is the root. So yeah, root is equal to tree node of middle dot value. I always find this annoying, because basically you want the node that's previous to the middle. Okay, fine. So previous is equal to none. Previous is equal to middle. Something like that, maybe. And so then that I can now do here. If previous is not none, it's a little bit yucky. I think we can probably do cleaner, but let's get it correctly the first time, and then we'll see. So basically, what I want to do is just, I don't know if I'm supposed to manipulate this. I know that I am not generally a fan of changing the input, but for now I'm going to change the input a little bit. So I'm going to break my rule. But imagine that if you're not lazy, you just create a clone list of this. So if you do that, that's fine. We can maybe even do it later if that makes sense. But it doesn't. I mean, it doesn't change complexity other than space complexity. So we'll just go with analyzing it in a more complexity way. But basically, just bisects the list now. And of course, we're going to set middle dot next is none. But before that, we go next. I can't spell next is equal to min dot next. And then now root dot left is equal to get BTST previous. Nope, we want the head. And root dot right is equal to get BTT of next. Something like that. And then we return root. I think we probably missed some stuff here. So if n is equal to 0, we return none. If n is equal to 1, we just return node. And this is node, not head. So I actually have to change some stuff here as well. This is node. Yeah. May have some off by 1 and stuff like that, but conceptually this is okay. Divide and conquer. None object has no next. That's fine. I mean, well, that's not fine, but that's an easy fix. Let me just put in all the test cases that they give you. So basically middle is none because head is none. Oh, because I'm using head again. This should be node. The head should not be none. Oh, maybe that's the input. That is the input here, but that's a little bit awkward. List node has no attribute dot left. Did I put the wrong thing? Isn't the tree node? Tree node part is right. So did I mess up somewhere? That's hard to figure out how to basically they're telling something about their own code, but I don't know how to interpret this per se. Let's see. We don't change anything, do we? No, nope. Yeah, okay. I think this is actually technically while current is not none. Maybe that's a little bit better. I think it's the same except for now I don't need this, but and maybe I have an off by 1 as a result. I don't know. Okay, that's awkward. What do I do that makes it has no attribute left, which makes sense, but why am I returning the thing, right? Root will always be a tree node, so why is it not a when is root not a tree node? Does this not return a tree node? Oh, whoops, if n is equal to, that's right, whoops. That's because this is middle or node dot value. Okay, whoopsie daisies. That is one thing that's sometimes a little bit sad about Python is that, you know, the type safety kind of messes you. So this looks good. Am I confident about this? I guess I'm pretty okay, but I mean, it's a little bit nasty. I might have height based off by 1 stuff. We'll see how that goes. Okay, so that looks accepted. I mean, I thought that it may happen. You know. Again, so you can change this a little bit. For example, instead of using length, you can find the middle by using 2 pointers. You know, one that moves 2 steps, one that moves 1 step. But I don't think that changes anything. You still have, you know, the same amount of operations, give or take. So I don't think that matters, even though people care about. If you want to care about localization, then you would not use linked list. I mean localization of memory localization. But yeah, Yeah, I mean, I don't know. So this is accepted. Let's go with complexity. Length is obviously going to be O of n, and we call it every time. For each one, we divide it by half. So this is the classic, whatchamacallit, recurrence of, was it F? I don't even remember the notations on off my head anymore. It goes to O of, n plus n of n over 2 times 2. So, and this is of course, n log n. So yeah, right? It should be, right? Because otherwise I'm just really bad at this. Yeah. So that's pretty much it, really, right? What else is there to say? Yeah, and if you need help proving this, read up Master's theorem, but also just playing around with recurrence. There are couple of courses that I don't have any different insights to this other than just learning it. In terms of space, this does get, as I said before, I am being very lazy in this problem, so I do change the input, which you shouldn't. So you should reuse this. You could maybe be a little bit clever in general by marking it so that you don't. Basically, the reason why I changed this to none is so that I considering a chopping of the list, but you can have other ways of representing it, perhaps with a left right or something like that, but there are a couple of ways of doing it. It's up to you, but in either case it is still going to be O of n of space, because at the end of the day you still have to return a new tree, and a new tree there's going to be one node for every one tree node for every list node, so that's going to be O of n, or linear space. And as we talked about, this is n log n time. So yeah, that's all I have, really. Let me know what you is this right? That'd be funny if I'm gonna no, yeah, there's log n of these, right? So log n of these, and each of these are n. So yeah, should be right. If not, I am just, my apologies. But yeah. Huh. That is awkward though. Yeah, okay. I mean, I don't really have much to say beyond that, so yeah, I didn't even look at the constraints, because n log n is going to be fast enough. Can you do this in linear time? Let me think for a second. Maybe you could do this in a linear time if you're really careful. Because you can think, actually you can definitely do this in linear time if you're really, I mean, it's trivial, or there's another way of doing it in linear time if you, or maybe the clever way is not that trivial, but you can do it in linear time very easily by converting the list into an array, and then converting that array into a binary search tree, just by the virtue of having it being a complete list, right? Is that true? Because for each item you get SS1, so that would be linear time, I think. Could be wrong. So I don't know. Do you make sure you prepare? I guess I'm a little bit. It's 3:40 a.m. right now, so I'm a little bit tired. Let me know in the comments what you think it is, and let me know what you think. Maybe I'm wrong. Today I'm a little bit off. So yeah. Anyway, hope you stay good, stay safe, stay happy, and to good mental health. I'll see you later. Bye bye.